In this video, I'll do something a bit different. I'll show how you can interact with the Arduino. This sketch is made with the Arduino Nano, but it can be done as well with the Arduino Uno. Same pins, same logic applies. For better understanding, the Arduino is mainly looking at C++ language. So the main programming language is C++. It's meant for robotic, mechanical, or other type of application. It's very good for beginners, learning programming as well. You could use the Arduino for you could use the Arduino with other languages like Python or more advanced languages, but C++ is very basic and mainly the foundation of logical programming. You'll see as well that C++ leverage functions. You're mainly calling functions left and right constantly, and that's what makes it easy. And I'll go through several of them. You'll see in this sketch I'll be using the serial available, serial parse integer, serial print line, serial print, pint mode, digital write, serial big end, while, and a for statement. There's other commands for reading variable types, so when you're interacting or asking question, waiting for input, you could use as well a string for serial monitor. So there's a function called serial read string or read string until, which we'll go into in another video, I guess, because right now there's plenty at this time. Let's go through a sketch, basic sketch. C++ is a very nice language to know. It's very straightforward. It mainly uses functions. So you'll notice that I'm constantly calling functions and applying logics in the program. I'll try to talk as I'm setting up the sketch here. So you'll notice that there's two, or actually I should say three main parts in a C++ program. You have main function like the void setup and the void loop. Void setup to initialize variable only once when the Arduino is boot up, and the loop, which is the heartbeat of your program. So it's constantly running lines of codes that you introduce in this function in between the brackets. You can use the top portion or bottom portion mainly to call in global variables. So you want to use that as well. It's important. Sometimes you want to declare a variable that needs to be reinitialized constantly, not just once. That's sometimes why you'll get some errors. You'll input a variable in your setup where it has to be globally declared. So like in our program here, what I want to do is, using the Nano and the LED, I want to ask a question to the end user and wait for an input. So I'm going to ask them how many times the LED should blink. So this is very basic and it can be modified to apply to other projects like opening a door, rotating a servo, a motor, and so on. So let's go through the sketch I want to build. So basically there'll be some important variable that I always want to keep track of. So the input of the end user, and which pin is being used for the LED. So if we initialize or we declare a variable that will store the input of the end user, let's call it, let's say blink time, and that will be used to store the value. And we also have LED on pin number 3. So what we can do is call it red LED pin on pin number 3. I think that's good enough. Now we can jump into our setup. What we want now is declare a pin mode. So since there's going to be an output on the LED, we're going to use the pin mode function. Pin mode, and you have to be careful, it's case sensitive. So pin mode, we want the red LED pin to be set as an output, right? Each time it's going to look at the number of blink time we ask the end user, it's going to put an output to it. So we need to make sure that it's capable of doing this. Then what we want to do is make sure that once we boot up the Nano, the LED is not on, it's on an off state. So we'll use a function again. This time it's going to be digital write. And we want to say, well, for the red LED pin, red LED pin, we want to set it to low to begin with. And because as well we're using serial communication, we want to start and open the port. So we'll use another function, serial begin. Now you can use different baud rate, and the most common used one is 9600. So I believe this is all we need to start with. So let's jump in our main program. So we want to ask the end user a question to begin with. So what we'll do is, again, rely on a function called printline. And inside we want to ask or input text. So we want to ask the question, how many times do you want the LED to blink? And because now we're waiting for an input, what we'll be doing is use a while statement and use the function serial available, and we want to wait for data to be received, so data that will go through the serial port. So we'll use a function and a while statement. So let's put that in space. While we want this, while we wait for the serial to be available, and that's a function. Wait if there's no data being sent, or wait if it's 0. So you can look up the while statement. Use brackets, so you can input logic inside, or you can as well leave it as is, not put any logic, and what's going to happen is just wait. So there's nothing needed in between the brackets. So instead of dropping the last one down, I usually keep it like this so it's clear in your code. So while we wait and until there's actually an input, we want to capture what the data from the end user. So what we'll do is we'll use the serial parsed integer function, and we had a variable called blink time. So we want to store it in the variable blink time. So if we tell the computer, well, I want the blink time to equal whatever is going to be sent from the end user. From the end user. Yeah, that's it. And for fun, if you want a confirmation or play with print line, you could do you have chosen number X and then start the logic of the program. Let's say for fun you do serial print line function, or let's skip a line here. Let's say you have chosen number, close this, and then you can say serial print line function, and this one we want to say print the blink time. So the value that's going to be captured from the parse in function that is stored in blink time, show us what's going to be the value here. And we can throw in a nice little function again just for the heck of it, a delay, another function. So 1000 equal 1 second, wait for a second, and then start our program. So ask the question, wait till you get an answer, store the answer into variable blink time, show what number has been captured, delay. So now let's say you put in a number from 1 to 9. We want to blink the LED that same amount of number. And how you do that is with a statement. A for statement is awesome. It's good as a counter. There's several ways of doing this, but this is pretty much the basic. So a for statement, it's kind of similar to a function. You will store activities or logic inside, but you want specific things to happen in order to kick in or to start. So first of all, we want to build a counter. So let's name it, we always go like this, integer counter. It can equal 0 or 1, but you want to pick 1 because you want to start at 1. You don't want to start at 0, 1, 2, 3, otherwise you'll have to change the logic in your program. So 1 is the basic. What's the logic? What's the condition? Well, we want the counter to keep going until it matches the value of blink time. So keep blinking until you get to the point where, let's say if it's 3 that they chose, do it 3 times and then stop. So you want to use operands, and until equals, or until the counter is smaller than blink time or equal to blink time, keep counting. And of course it's blink time, the variable we want to compare to. In order to keep counting, you want to go and increment the counter. So you could increment, you could have minus. Look at the references for Arduino. You'll find tons of information on that. So now basically our skeleton for the for or the counter is built. So what happens here? It's pretty basic. You want the LED to blink X number of times. So the first logical line that you would need to put in is, well, the first time it's going to run, you want to do what? You want the LED to blink. So we're going to use another function called digital write. And we want to write to which pin? You remember where the LED pin is? Yes, it's on number 3. But you need to use the name of the variable. So write to the red LED pin, and we want Y. Right now its current state is low, so now we're going to put it high. If you want to do a blinking pattern, well, the logic would be once high, you want it to go low. But you don't want to go super fast, so you're going to put in a function, and we'll say, let's wait a second. And then once the second pass, what do? You still go and ask the computer to write to the red LED pin, but this time you want it low. And just to throw in another function, let's throw in a delay. So reread, perfect. Let's reformat. One thing to look time to time is the compiler. Compile your sketch. See, we got an error here. You see, I had an error. Parse int. It's perfect. It's done compiling. So let's go through the sketch, global variable, initial setup, and the main program. The sketch, so connected to D3, use a resistor. If you connect your LED directly, you might blow it. 5 volt is quite too much, so bring it down using a 1k ohm resistance. Negative goes to negative, close the circuit, so we're good to go. Open the serial monitor, and right away you get the question, how many times you want the LED to blink? Let's say twice. It's in a low state, so 2, 2, off. And you see the logic, it captured the input, printed the input that was captured, and it always goes back again over and over until, I guess, you build in a AND program. So let's try 3 times this time. 1, 2, 3. Well, there you go. This was your first lesson in learning how to interact using serial communication in Arduino. It's not just about building mechanical projects with motors or robotic arms, but you can as well create interactive screen or menu for the end user to input and perform a specific action. In order to have success with this sketch, don't forget to switch to no line handling. As you can see, it's very straightforward. You initialize setup variables or declare variables. Inside a loop, you basically have your main program. As seen here, goes from up to down. So you ask a question, wait for an answer, save the answer into a variable, print out the value of that variable, and then start the program to blink the LED. So based on the answer from the end user, run this this counter 3 times. With the inside, you'll find a logic that says what to do basically, and here is to write the pin high, low 3 times, or X number of times the end user picked. Set yourself a challenge. One good thing is, I love with Arduino, is setting yourself a challenge. There's so many things you can do. One you could do is have another LED, maybe a green LED, and in your question ask which LED you want to open. Press 1 for red LED, press 2 for green LED, and bit other logic. Do a bank machine. You could do so many things. This is mainly the basic. Use the reference Arduino reference library. I'm gonna post the link in the description with all the functions that I've used in this video. I'm telling you, it's amazing. Once you start learning and you capture the concept on how the logic works with C++, it's going to be very easy for you to implement other projects and be successful.